from the back we had flip-flops, and then counters, PWM, multiplexes. Right, so it's on my list. I guess you don't need to see it right now. But let us begin where I said we'd begin with alias frequencies and sampling. So, where's my stuff? So let's jump right to the back of the packet here with a multi-part question actually on this topic. So this is actually from, it looks like it's from an old test. Can you guys see that? I probably need to zoom in. Okay, this is it's right at the back of your packet, probably like the third last page or something like that. Do I have all the pages in? So it says a sinusoidal voltage waveform, which is a cosine function, is shown here as a solid line collected on a digital sampling oscilloscope. This oscilloscope records only the values shown by the squares. So those are the sample points, the squares. Notice that the samples are taken every 0.5 microseconds. And then answer the following questions. Include units in your answers. Right, so it starts off as a relatively easy question. It says, what is the sampling rate? And what is given to you to tell you what the sampling rate is? 0.5 microseconds is the sampling period. Right, that's given right there. So that's the period. That's the sampling period, I should say. Right, so the sampling rate is 1 divided by 0.5 microseconds. Right, so this, let me write that in seconds as 1 divided by 0.5 times 10 to the minus 6, with seconds in the denominator. So if we write that, if we calculate that, that's 2 times 10 to the 6 hertz. Right? 1 divided by seconds is hertz. Hertz is the unit for frequency. So this number of cycles per second. And that's much better described as 2 megahertz. Come on. Well, thank you for telling me that. Okay, so I'm going to have to zoom out. Okay, there we go. All right, so that's an easy start to the question. The next question is, what is the frequency of the sinusoid? So essentially, a very similar question. You have to compute the frequency, and you're going to use the period. But finding the period of this sinusoid is it's not given to you. How would you go about it? Right, you're going to have to measure it off the graph. So one period of this sinusoid can be thought of as one peak to peak. Right, one peak to peak, as I've indicated there. And it's really hard to read what that's going to be. So that's not actually the way to do it. You should take several periods of this sinusoid. So I'll label that, if that's the 0 point, that's one period. 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are 10 periods depicted here. And the 10th one ends at 12 microseconds, right? 12 microseconds. So the period, so sinusoid period, is the total amount of time that has elapsed, 12 microseconds, divided by the number of periods there. So the number of entire cycles there. So the sinusoid period is 1.2 microseconds, and therefore the frequency is 1 divided by 1.2 microseconds, and that number is not a round number. So what was it? So that was, I guess you were allowed to calculate on this test. That number was 0.833 megahertz. Okay, so those were sort of preliminary questions to set up some of these questions. So, will this signal experience aliasing? So I see a lot of people say no, and that's correct. No aliasing, and why is that for those people who said no? Yes.
Sampling rates more than twice, or more than the Nyquist sampling rate, which is more than twice the frequency.
Right. The sampling rate, which is 2 megahertz, right? That's f sub s, is more than twice the f. 2 megahertz is bigger than twice of 0.833 megahertz. Right, so the reason for that is fs is greater than 2f, right? And so the next part D asks you, why there is no aliasing, the exact same question I asked you, but none of the options given to you are equal to, are this reason that I've given right here. None of the options are this. It's because they don't ask you to compare fs to f, they're asking you to compare fs to f Nyquist. Right? F Nyquist is 2f, right? So that's an important definition to know. And therefore, the equivalent statement is this one here, that fs has to be, the sampling rate has to be greater than the Nyquist rate.
Well,
yes?
aliasing occur if the Nyquist is equal to the sampling rate?
It may occur, yes. That's sort of like an ambiguous. I'm sorry? So strictly speaking, the sampling rate has to be greater than the Nyquist rate, not equal to it.